we're first going to find the mass of the object.
We'll do this by using conservation of momentum.
And in order to find the mass using conservation of momentum, we have to plug in the velocity equation that we're given. And by mathing that stuff out, you can end up, while using that t equals 0, you can end up with a mass of 500 kilograms for the object.
We did that using conservation of momentum. We did m1v1 plus m2v2 equals m1 plus m2vf's v final. And our givens are the final velocity is 8 over 1 plus 5t, m1 is 1,000 kilograms, and v1 is 12 meters per second. We then plugged those into the equation using 8 over 1 plus 5t as our velocity final, and we plugged in 0 for t because the time is 0. After doing math, you can find that 4,000 equals 8m and that the total mass is 500 kilograms.
Now we're going to find the position function of the system using calculus.
Ooh, calculus. We get to use the integral of the velocity function to find the position function with respect to time.
And knowing that time equals 0, we found the expression for the position to be 8 over 5 ln times 1 plus 5t.
And we did that by using that velocity as the derivative of position. So we took the velocity equation, which is 8 over 1 plus 5t, and we put dt on the other side, and then we plugged in, we made 1 plus 5t equal to u. And from that, we got that dt equals du over 5, and we took the integral of that to find that the position function was 8 over 5 ln of u plus c. C is 0 because the position is 0 at time 0, and we found that the position is 8 over 5 ln of 1 plus 5t.
Physics break!
We're going to be using Newton's second law to find the resisting force on the system after the collision.
Yeah, so in order to find acceleration, we had to take the derivative of a velocity, and since f equals ma, our acceleration was found to be negative 40 over 1 plus 5t squared.
Yeah, we did.
In part C,
and our
we had to
resulting
find
force was
the force
negative
that was
6,000
applied to
over
the
1
object.
plus 5t
We used
squared.
Newton's second law to find this, knowing that f equals ma. And in order to find acceleration, we had to take the derivative of velocity, which we found to be negative 40 times 1 plus 5t to the negative second. Our given mass is 1,500 kilograms, and we plugged those two in to find that force is negative 60,000 over 1 plus 5t squared.
Now we have to find the impulse delivered to the car object system from time equals 0 to time equals 2.
Then what are we going to do?
So, in order to find impulse is mass times the change in velocity. So we found the change in velocity from 0 to 2 seconds, and we found that to be approximately negative 7.2.
In part D,
So
we
the
had to find the
final
total
impulse we found
that
was
is
negative
given on the system.
10,909.091
Impulse is mass times the change in
Newton
velocity
seconds.
or change in momentum. So we did the mass of 1,500 times the velocity at 2 seconds minus the velocity at 0 seconds. which we found to be 8 over 11 minus 8, which is negative 7.273. And we found that the impulse is 10,909.091 kilograms times meters per second, or Newton seconds.
Now we're going to find the position function of the... Wait, did you stop recording?
We're going to start by finding the mass of the object.
No, you have to talk.